Hello, everyone. Welcome to the Flight Community Sync, building AI better together. My name is Niels Ben Thielen. I'm the Chief ML Engineer at Union AI, and I'm super excited to bring on our guest for this week, Deepyaman Datta. Deepyaman has been in the data and ML space for many years now. He was a Quantum Black, Claypod AI, Voltron, Dagster, to name a few places he's been at, and involved in the open source community as well in the data and ML ecosystem, where he most notably is a maintainer and contributor to Kedro, and also Ibis, which is one of the topics for today's talk. Cool, so let's go ahead and dive in. We're going to chat for a little bit, and then Deepyaman will show off a little demo of today's topic, which is the integration between Ibis and Pandera. If you don't know what those two projects are, it's okay. We'll unpack it during the conversation. But just to get started, Deepyaman, can you share a little bit about your background and kind of how you came into data and ML into this space?
Yeah, sure. Yeah, and thanks for having me. Really excited to be here. For myself, I started off as a software engineer, but I ended up landing in a team that was doing some data warehousing, got a taste of it, some of the reporting aspects and things like that. But I really wanted to kind of get more into ML, and data science was the hottest job of the 21st century before. I guess it comes and goes, things change, but it was something I wanted to do, went to grad school, and then I got involved with kind of most notably at Quantum Black. I was initially a data engineering lead across kind of projects at a variety of clients, really getting to see like how people at a lot of different like Fortune 500 companies, things like that, were working with data, trying to build like data pipelines. That's how we really got involved with Kedro as well, for how do we kind of build some of these data pipelines. And then over time, I got into working more on the developer tools side of things, getting to solve, I guess, some of these pain points, which I really felt as a data engineer or a machine learning engineer myself. So that included, contributing back heavily to Kedro, later getting to work on, as you mentioned, Ibis, sort of fortuitously when I went to Voltron Data. And then that's also in a way how I got to learning about and then eventually contributing to Pandera.
Awesome. Yeah, thanks for sharing that. So what is, you mentioned Kedro. I think it's important since we are in sort of like the Flight and Union community, which is all about orchestration and pipelines and things like this. So for just the audience who maybe have not heard of Kedro, what is it, and how did you get involved in it?
Yeah. So Kedro is an open source project. Much like Flight, it's actually part of the Linux Foundation, LF AI and Data Foundation. And what Kedro focuses on is kind of bringing some of your software engineering principles to, well, data science code, could also be like data engineering code. But the way I like to think of it is it's like a transformation framework. I know that maybe a lot of the audience who's kind of more focused on AI ML may not be the most familiar with DBT, which is like a SQL-based transformation framework. But one of the easy ways to think about it is like it's a way of structuring your transformations that are Python first, and it allows you kind of build up like, which transformation runs after another transformation, and building up these dependencies. So it basically gives you a way to kind of like structure code. It has other functionalities like how do you kind of abstract out like the data saving and loading aspects using concepts like a data catalog. It has things like pipeline visualization, very extensible plugin system. So as an example, let's say that you want to do data validation, you can use its concept of hooks to be able to run validations before or after your data is getting loaded or saved, something like that. And then the other thing, since you did mention like flight, orchestration, I've also worked in the orchestration space myself. Kedro itself is not an orchestrator. So the use is, so it's especially useful when you're, let's say if you're working kind of locally or experimenting and you want to be able to structure these like transformations and do it kind of in a more reproducible way. And then Kedro has a concept of runners as well, which allow you to say, like, okay, I can run, let's say, my nodes in my pipeline sequentially, locally or something, or I can parallelize them. Or I could choose to have a custom runner that's running them on something like Flight or Airflow, depending on kind of what sort of use case you're looking for as well. It helps with, in a way, the separation between your transformation logic and your orchestration logic.
Gotcha. So is it accurate to say that the main focus of the project is to bring kind of software best practices to data science, data engineering heavy, like in terms of a target audience, right? Like bringing those practices into those disciplines?
Yeah, no, I think that's a very much the high level goal.
Cool. Let's see. It looks like my video may be frozen.
It looked like it went dark here.
Yeah, 1 second. Sorry for the technical difficulties.
Hopefully Niels will be back here in a second. But
Yep.
while we're waiting for him to rejoin, if anyone's watching and maybe has questions, feel free to put them in the chat as well. And if something catastrophic happened, like his computer completely died, I know that you have some code that you can present as well that maybe we'll just get to a little earlier than than we were expecting.
Yeah, absolutely, we can do that. Let's see.
But does anyone have any questions watching live right now? Let us know in the chat. Here's Niels.
Oh, there we go.
Quickly switch computers. Oh boy. Okay. Sorry about that, everyone. Okay. So I guess let's maybe pick up where we left off. What did you learn from contributing to Kedro? Was this your first open source project? What is that experience like?
Yeah. So Kedro wasn't the first open source project I've contributed to. I'd made kind of minor contributions to, I think, something like matplotlib or some other visualization libraries and kind of various other projects here and there. But as I think a lot of people who've maybe tried contributing to open source knowing it can be challenging or daunting to kind of get into it. Kedro was something where I was fairly early on a project and I was also using it very heavily. And so I was contributing back quite a bit as I was using it, fixing things, adding like various data sets, updating things where like, oh, there were performance issues, whatever. Yeah, over the course of just many years, I started contributing to it in 2018, back when it was still a project within Quantum Black internal. And then it got open sourced by Quantum Black McKinsey in summer of 2019. And I've just been involved with it ever since. So I've actually never really been kind of like somebody who's kind of paid to work on Kedro sort of thing, but as a kind of avid user and and also somebody who kind of really believes in the premise of it. Just got involved with contributing heavily, and now also I trying to figure out like where does that kind of fit into with the broader like data engineering, data science ecosystem, and what people should use.
Yeah, cool. Yeah, I guess in the end, I'm always curious what motivates people to do open source. I guess everyone will have a different answer, but I guess I'll save that to the end because it's kind of a high level, kind of philosophical question maybe. But yeah, let's pivot over to Ibis because I want to eventually get to Pandera.
Of course.
But for folks who don't know too much about Ibis, can you just give the elevator pitch real quick?
Yeah.
For that?
So Ibis is a Python data frame API. So it looks quite similar to something like Polars or even like a PySpark API. And for people who are coming from the R side, you'd also probably see a lot of parallels to something like dplyr. But it's a Python data frame API that allows you to kind of work with any backend of your choice. So Ibis supports 20 plus backends. This means that you can run maybe locally on something like Polars or DuckDB, or you could run in more distributed setting using things like PySpark or BigQuery or Snowflake, or in the later today we'll see something with like running on Trino. And it allows you to kind of use this single API. It executes things in a way that it's actually getting run on the back end rather than kind of pulling data locally, and so it can help you kind of do things efficiently at scale, like the power of SQL, but with a like familiar Python syntax.
Cool. Actually, I've been curious since Pandera does. It's not the same project, obviously, but it has as a maintainer and an author. It's dealing with this problem of single API, multiple backends, having to write sort of like in this case the Pandera way of like integrating with different frameworks. How does Ibis, in your experience, handle this challenge? I mean, like, are you're transpiling to SQL and to the various other backends, and what are the abstractions and things that the Ibis project does that helps the maintainers manage all of that complexity potentially?
Yeah. So Ibis has that like data frame API layer, and then that data frame API layer allows you to kind of construct an intermediate representation, which is essentially like a syntax tree that builds up what's the kind of whole query that you want to execute, and then there's a process which compiles that syntax tree, that intermediate representation into the kind of dialect of your choice, or like whatever the backend is going to be. So I think 19 of the 20 backends that Ibis supports all kind of compile to SQL. Last I heard, even if kind of like the Polar SQL was to kind of get a lot more mature, then probably Polars would also be supported through SQL. Don't quote me on that.
Yeah.
But essentially, yeah, there's a compilation process. Then there's a lot more kind of complicated pieces, like for certain cases or inefficiencies. There's also like potential like rewrites and things like that. And then I think that also another very cool part of Ibis is, well, not a user-facing part, but how do you actually make sure that this is correct? One thing is to just say, oh, I've translated into the SQL dialect corresponding to Trino or ClickHouse or something like that. But Ibis has a massive test suite that runs every time you make a commit, that is going to actually check that given like certain scenarios, certain set of inputs, if you do certain like transformations with Ibis, it's going to give you the expected outputs. And yeah, it's not like there are cases where backends will handle these a little bit differently. But to the extent possible, Ibis tries to guarantee that you can expect a consistent result without being kind of overly limiting or restrictive. The lead for the Ibis project, he's actually kind of given a talk on like how this testing works, which is a very complex, interesting project in of itself.
Yeah. Are these tests unit tests they can run locally? Like, does each backend have like a way to I know for PySpark, there's a way to run things as if you're hitting a remote PySpark instance or cluster. For all the backends, is this the case, or is it kind of case by case basis?
I'd say that it's for most of the backends, most of these engines, you can set up kind of a local execution of sorts, and some of these are easier than others. But for let's say if you're working with Postgres as a backend, you can still spin that up in kind of a Docker Compose environment, and you can kind of set this up, and it's connecting to that, executing queries using that backend, and that will work. There are certain backends, like for example, Snowflake, Databricks BigQuery, which you may not, if you're just kind of like somebody contributing to something like Ibis, you probably won't go and run the tests against these cloud backends from locally, because you don't have access to the kind of cloud test environment for this. But overall, yeah, it's overall for most of the backends, you can test this locally. Even I got into Ibis actually before I was working at Voltron Data, when I was at Claypod AI, working on the Flink, so the first streaming backend for Ibis, because that's something that we were trying to build to use under the hood of a real-time feature platform. And for that also, again, you can just set it up through like a Docker Compose environment. So that works for most of the things. And they're unit tests. You can, so also when you're like adding a new functionality, first you may just test it against one of the backends. DuckDB usually works pretty well for testing. And then you can also rely to a good extent on the CI to run it across all the other backends and make sure your contribution actually works.
Gotcha. Yeah, this is partly why I reached for Ibis and various other projects, because Pandera now supports various dataframe APIs, frameworks, and it starts getting unwieldy to support all of them. So I'm hoping, like Ibis and then maybe narwhals will be kind of the last two integrations in a sense.
Yeah.
There are some libraries like Xarray that I'm interested in, and there are a handful that are interesting in the sense that I think Daft dataframes, for example, handle multimodal data, so audio and video and image really well. So there may be a few exceptions here and there, but yeah, the one thing that's kind of a engineering challenge is how do you test and do unit tests and integration tests for every single like permutation.
Yeah, and I mean, as you obviously know, as a maintainer of a very popular project, like there's a big cost to also, let's say if you're going to go support like BigQuery, like big frames as like a backend, and then you're going to support like another, like if you go and explicitly support like the different snowpark variants, and if you just keep adding for each different system, then that's just even more for you to maintain, for example, as like a Pandera maintainer. And there are some like trade-offs. That means like maybe you can maybe people who are writing some custom checks can use the like kind of dialect they find most convenient for expressing these custom checks. But I mean, in my personal opinion, I'll say there's also like kind of a pretty, there's a trade-off in the sense that with Pandera, part of the thing is you don't necessarily need to write that many custom checks, because part of the benefit is it comes with a library of all these useful built-in checks. You're not having to do this from scratch. And so if you're only doing this every now and then, I mean, it's not a big deal to learn Ibis or maybe narwhal's syntax, which are pretty familiar, and just express your little bits of custom logic in those cases.
Yeah, I think people coming from things like PySpark or Polars or dplyr, if you're coming from R, should be fairly familiar with the concepts, like lazy, execution graph building. You materialize it all in one go at some point in your pipeline. Cool. So I guess before we dive in even further into this integration, I just want to get a sense of what were some of the pain points You don't have to mention data validation or valid data, but in your, before you encountered Pandera and kind of throughout your career, what are some of the big pain points in like the machine learning production line, let's call it?
Mm-hmm.
So this is not like Gen AI even, this is just like classical like logistic regression or very narrow, well understood applications where you have a data set, you train a model. Like what are some of the things, the pain points, and like we've already talked about Kedro solving some of these, Ibis solving some of these. What are others that you've seen?
Yeah, I mean, I would say like the reason I got into a lot of these things, including and where I kind of also saw some of this Ibis stuff fit in, was my experience as a data engineer at Quantum Black, working with a lot of kind of clients across various organizations, was we would be often building our all sort of like data engineering parts with the intention of kind of being used for an ML use case in the end using Python. And a lot of times this basically meant like, okay, if we're going to do it locally, we use pandas. If we're going to be able to do it for scale, we use PySpark. And I think that part of the kind of challenge is that that's still the mindset of a lot of people. I think like Polar's done a very good job in terms of being like, okay, maybe we use Polar's locally. But then a lot of people I think will still think, okay, unless you're kind of working like kind of very tech forward, sophisticated organization, you're just like, okay, PySpark means scale.
Yep.
And it can be a good solution. It can also be a lot of times overkill. It might not be the best solution if you're kind of working with kind of database backends. I remember working with some client-facing engineers who had all their data at the client in Oracle, but then the pipelines they'd already built were in PySpark. So they were essentially reading things into the PySpark cluster from Oracle rather than just doing some of the compute on the database, which you would do if you're working in SQL. So I think one of the biggest challenges was like from a Python perspective, having the tools to be able to kind of conveniently and efficiently work with data across a lot of these different systems. That was definitely that's definitely one of the biggest challenges. I do think that with some of these tools like Ibis being available now, like again, this is my personal opinion, I do feel like Ibis is in a way pretty revolutionary technology in terms of it really opens up this whole new world for people who are Python-oriented developers. And also for the fact like I've seen some people doing pretty cool things where like, for example, they'll develop their pipelines locally using Polar's backend for Ibis, and then they're running in production in Databricks on Spark and using essentially the same code without having to change it. So helping with that kind of helping ease that, like one of the things of productionization journey you mentioned is moving from development to production is a lot of times it's just a rewrite or you have like machine learning engineers is such an overloaded word, but sometimes machine learning engineers is essentially the one that data scientists throw code over the wall to and be like, hey, can you rewrite this so it's actually performant and scalable? And so I think that's again like another of those big challenges that there and like of course you still very much need machine learning engineers to think about do that like system level thinking and to think about like, for example, on like, oh, how do I do like really efficient inference or something, or like various problems are still there, but maybe that translation doesn't need to be part of it.
Yeah, absolutely. So yeah, I feel like all of those are pain points I've definitely felt in the past. The one let's pivot over to Pandera. I think the one that is not really a pain point until you get bitten is when you have like silent errors passing in your data set, right? And so this is, quick elevator pitch is Pandera is basically a toolkit for writing schemas, contracts for your data. And so let's say you have a pandas data frame, anything can be in there. There can be any number of columns of any number of types and values. So that's where you can write a schema in Pandera, which effectively is your data contract for typically. It's a data contract that you typically use at the interface boundary between, say, let's just call it sort of software boundaries. So maybe you have like a database somewhere, you query it and you load it into memory, into pandas. What needs to blow up for you to know that the data you're dealing with is not as you expect it to be? You might have like some manual documentation on Jira or like Notion somewhere, and you're kind of like using that as your source of truth. But the thing Pandera solves is both documenting the data directly in code and then actually enforcing it at runtime. So with that out of the way, where did you see the connection point with Ibis, the stuff you were working with, and then Pandera? Because I know there's been a Kedro Pandera thing, creation. Like, how did you learn about it, and how did you decide to contribute?
Yeah, I was trying to think about this. Like, I don't think I learned about Pandera through the integration per se, but I think it was through some of these colleagues, including some who I think some of the other maintainers of Kedro who decided to kind of later on go and build the Kedro Pandera integration. But the way I started hearing about it was like just seeing more practitioners reaching for Pandera for data validation. I'd worked with kind of other data validation frameworks before. Great Expectations was a pretty popular one, but I'd seen a lot of people then starting to talk about Pandera and really liking that and using that more and more in conjunction with tools like Kedro or in general for their data validation needs, especially because it's lightweight. And I think one of the kind of biggest things that stuck out to me is that if you need to do data validation at some point anywhere, you can kind of just use Pandera. You don't really have to necessarily think about you're not really centering your workflows around a data validation framework. It's just a kind of library or tool that you can use wherever it's reasonable. Even with like some work, for example, like orchestrators later is like, okay, if you're doing these checks, and rather than like a lot of times, like everyone's not going to have a whole big built out library of checks and a way of kind of executing them. And having a tool like this, something like Pandera, I think is really valuable. I will also say that sometimes I see like, a new validation library just dropped, like for polders or something like that. I am personally a big fan of not reinventing the wheel. A lot of times I do see some of these and I'm like, my first question is always like, kind of what does this do that's unique, that is not handled, for example, like when you had the polars backend for Pandera. I think a lot of times there isn't really anything unique, and people just reach for like, I could write a validation library, which is cool. But
I wholeheartedly support any attempts, right? Because I don't think any given project can take for granted that it'll get everything right about the design. So Pandera itself has gone through a couple of redesigns that luckily have been kind of backwards compatible. But yeah, it's the open source ecosystem, right? Someone created a Pandera-like library that's just for pandas, because I think he or she or they saw the dependency graph from all the different requirements files that I had for like CI. They're like, why does this have 1,000 dependencies? And then they went off and like wrote their own library, and I'm like, oh, dang. I followed up on the thread, but it was already too late. This person had already written this thing, and it was like a couple of months in, and they were using it at work, which is how Pandera started, right? So I think it's legit to like go off and try designing something for a specific kind of to couple with a specific tool, which is I think that's a totally fine direction, because the trade-off is you can do special things with that library. Like I think there's a polars one called Petito, which has its own set of APIs and its own like extended functionality, which I think users of that library enjoy. So yeah, it really just depends on like the design of the project and how specialized you can make it, depending on like what dependencies you take on.
Yeah, and I mean, I think of course, like in a way, this is always a good forcing function for example, like some of these established projects to be thinking about like, oh, how can we also cater towards these sorts of needs that maybe are being addressed by some of these newer frameworks, like how do we make it more extensible? Or I think you did some work recently that I saw that on not making pandas like a core dependency of Pandera, like kind of separating out those dependencies more. And yeah, I mean, it's like as you see people's pains and as you see like other projects come up, then it can be like, hey, we can be inspired by that or something. And that's
definitely. That was definitely a request from the community who had pointed out various other projects who did not, they just didn't want to have to install pandas to just use this for polars, for example. Okay, so I guess I was going to ask what problem does the Pandera Ibis integration solve, but I think maybe you can show rather than tell. So if you're ready to switch over to your screen share, you can take us through a quick demo that you prepared.
Cool. Yeah, I think I've got it up. Let me know if you see the screen.
I see it.
Okay, great. Yeah, so I'm just going to go through like a really simple demo. I'm not going to really focus on showing too much functionalities from across Pandera. I'll probably just do a pretty simple use case, but I will, like one of the things I do really want to show is like how you can kind of work with stuff locally, and then also how you can kind of do things at scale, and how kind of Ibis helps power this sort of experience and reuse. So I am going to start off by just kind of loading this data locally. So this is, I don't know how many people are familiar with chess or the Lichess server, but in short, there's like kind of a website, if you know of chess.com. There's also a free open source chess server that's pretty popular called Lichess. And one of the nice things is they export all of their games, and you can freely use that data. So I like to use it for some of the demos. And I've just got a table. This is kind of locally that I'm loading with Ibis. By default, that gets loaded using the DuckDB backend. And here's our games data. We can see like, oh, we've got some game ID and information. This is all data from September of 2024. This is like a snapshot of, I think, like a day or a day and a half of data. And you see columns for like, for example, ELO is like a numeric quantification of like what somebody's level is. So the higher your ELO is, the like comparatively stronger chess player you might be. Yeah, so a lot of different fields in here. And let's see how big the data is. It's like 423,000, so 400, 500K games in here. And then, yeah, we can go into the Pandera side of things. So here, I'm going to go ahead and define a Pandera schema. And this is using the dataframe model syntax. Pandera has an alternative syntax around dataframe schema, which essentially does the same thing. But I'm just not going to do that right now. And here we can see that we have, so we're going to have like define some of our fields in here. So we've got our game ID. We saw like this, there's a site field up here, as well as our ELO numbers, and then our eco code. Eco is like encyclopedia of chess openings, because chess players have, yeah, like a whole code for whatever opening you're playing. And we're going to use a fancier rule here on like, oh, this is going to match a regex, that it can be like from anything from A00 to E99, I think. And then last but not least, we'll define also kind of one of the types of like more complex custom checks. This is just to show something. We'll do a like a check that goes across multiple columns. So we're going to make sure that, so if we look at this like site, which is essentially a link out to one of these games, that's going to end always with the game ID. That should be true. I think I actually had extracted this out at some point when I created the extract, so that should be correct. And yeah, so these are just some checks, and then we can run the validate method on this. And okay, so I got an error here. If I look down at the error message, oops, sorry. Okay, so it says expected column white elo to have type int64, but got a string instead. So yeah, that actually, I made a mistake. These are, even though they are kind of numeric fields, they should be represented as strings. Or sorry, they are represented as strings in our data set. We could also have modified our games table and already done the cast, but we can just do it this way. Let's just expect that they're strings, just because even for some of our data later, they'll be in string format. And if I was to rerun that validation then with that update schema, well, I basically see that schema.validate gave me that same games table as a result. That same object is there because the validation passed, no problem, no errors.
Yeah. And just maybe like a quick note here about the opinion that Pandera makes here is that by default, it will take the data as is. So it kind of gets out of your way in the sense that for the most part, you're kind of responsible for getting that games table into the right format. Pandera doesn't really do a lot of work just by default to try to coerce it into the valid state. Those are some advanced features like coercing the data types into what they're as they're specified in the schema. There's something that's called parsers, but we'll skip that for this.
Yeah. Yeah, that definitely skipped over a lot of the functionalities that Pandera has kind of built in. And yeah, so essentially, like, and we could have also called this in different ways. If we wanted to kind of chain other logic after this, we could have kind of applied the schema.validate as a chain function call within here, using something like a pipe method from Ibis. But yeah, this works right now just to kind of show that, hey, we can run these validations. One of the other things that maybe I should quickly highlight is I did turn on interactive mode here for Ibis. Ibis, like if you have worked with something like PySpark, or if you work with like Polar's lazy frames, Ibis is deferred or lazy in the sense that it's not going to eagerly go ahead and execute these compute, especially if you're working with large scale data. You don't want to necessarily run it on each time you're building up your expression. But when you run things in interactive mode, it is kind of doing it each time you run it. It's useful for demo purposes. So yeah, so we've got some working checks here. So I'm also going to go ahead and just connect to Starburst Galaxy. Starburst Galaxy is a managed platform where you can run Trino, which is kind of just another execution engine framework. It works on kind of large scale clusters. So you can see I've got a cluster set up within my environment, and I've got 20 workers on this cluster. So also for this data, it's going to just be like a expanded version of the data set that we were working with for that games data. But instead of being for like 1 month, instead of being for like 1.5 days, it'll be for the whole month. Yeah, we can maybe take a look once that cluster is up and running. And the other thing is, like, in terms of like how does this look different from our experience from Ibis? Ibis, just real quickly, like here we can see like we did ibis.trino.connect. That's just using the Trino backend. But once you establish your connection, the whole idea is that things are generally quite, they should work kind of quite in the same way. So Ibis, like that unifying API of sorts that allows you to define your logic in a way that you can reuse it across backends. Yeah, so I think our cluster is probably still, okay, now I think it just started running. If we look over here, okay, it listed a couple of tables. We have games table, move tables. This data lives in S3. I think compressed, like this is total maybe 25-ish gigabytes of data. Uncompressed, it's much larger. I think it's like at least 12 times larger, I forget. We can take a quick look at like a preview of some of this data. So let's get maybe a few games from there. It should look quite similar to what we had. Yep, so here we just have our game ID column, site column, our ELO and eco, like all of that information is still there. And if we were to look at how many games there are here, that's about 87 million-ish games for the month of September. All right, I'm going to turn off interactive mode just because, as we mentioned, like you might not want to do that when you're executing at kind of larger scale, that it's going to kind of eagerly kind of pull those back. But I can go ahead and run this validation. This is the same schema that we had before. You see that, okay, we've got this correctly as strings, and I can validate my data. And let's see. So it just takes a bit. I actually do know why, or I think I do know why it takes a bit to run here, and maybe I'll kind of mention that a little bit later. But yeah, it's running this check.
This is now validating all of the data inside the Starburst cluster.
Yes. And actually, we ended up getting an error, and we see that we have, okay, so column equal failed, that it's not matching this this regular expression. And so I've actually know that the problem is that some of the things in this larger data set for the eco code, they have a question mark. I guess it's like an unknown one. So if I run this right here instead, and I extend this regular expression to also to be either, it could be like that A00 to whatever, or a question mark. And I mean, I could probably even just like take a quick look here if I were to do like games.filter, let's see, eco equals a question mark. We could probably see what some of these looks like. Let's see, let's just look at a preview of it. Oh, my live coding worked. Yeah, so we can see that there are some things in here where the eco is a question mark, the opening is a question mark. It's probably not like a ton of them. So that might be why we didn't have it in our local data. Yeah, it's the total of like 163,000 out of that 97 million or 87 million. So we got a bit lucky, but essentially, yeah, when we did this, we saw that it worked. It actually ran like much faster when there weren't some errors. And if we want to, again, go ahead and like look at the result of that, and we'll just look at the head of it, then it's actually, so it's run the validations already, and we can again just continue using our data as this result. So one thing I just really, I found cool as I was just like preparing this was like, I can go in and I can look at the query.
Oh, that's cool.
Insights running here. Yeah. So this was, I guess, the preview query that I did. But let's take a look at this, which ran just, when did this run? So this ran at 10:44, and right now it's 10:44 my time. And if we look at this query, we can see that it is constructing this like regexp-like eco, like this specific regex that we did. We can see some of the translation it did here. It added the little caret. Pandera's logic is doing that. So it ran this for essentially our check where we're looking at the regex match for that eco code. Similarly, if we look at one of these other ones. So this section ended up being, I guess, a cached result, but maybe we can also see, let's see, that's a preview. But
that's cool. So you can actually see the Pandera Ibis turned into queries. The schema that you saw in the code cell basically is compiled into the SQL query through Ibis. And
Yep.
this will work across all supported backends, right? So like BigQuery and Snowflake and Athena and all that.
Yeah, and it's being translated into specifically the dialect that's getting executed for Trino. Here we can also see that example of like I create that like ends with expression in the Trino SQL. So ends with site game ID, and yeah, then there's the little bits of Pandera internals of how it's creating these like temporary column names and the like queries that it's going to use and how it kind of pulls this all together. So yeah, I just thought it was like kind of very cool to be able to actually see how it's getting executed on the on our distributed backend here. It's actually being done by the Ibis client.
And yeah, I just want to take a pause here because this is like Pandera has a PySpark backend as well, so that the that works in much the same way. But this particular integration, and big shout out to DPMN here, is now like Pandera can be used to validate 20 plus backends, which is pretty mind blowing. Like before, it basically was designed for pandas, right? And kind of had to evolve through the years to kind of support other pandas-like libraries. But with this particular integration, like it basically unlocks using Pandera in pretty much all the major popular, data warehouses, data frame libraries, and so on. So yeah, this is awesome to kind of see. This is the first time I'm seeing it in action like this.
Yeah.
Okay, cool. So yeah, thank you for taking us through this demo. What are some of like, I know we worked together for off and on for a few months as life gets in the way, and open source is sort of like this. You kind of spend time whenever you can to sort of contribute in this way. What are some of the things you learned integrating Ibis into Pandera? What were some of the challenges, some of the things that kind of were a little painful, maybe, and maybe the good stuff too?
Yeah, so I think like one of the things which was, I guess, challenging was, or like kind of like a new challenge for kind of working with Pandera with something like Ibis, which is a gateway to some of these distributed backends, is thinking about how do you correctly or kind of like nicely report some of these like failure cases and do this efficiently when your data is kind of distributed and could be very large scale. So I kind of alluded to this one before, where when I had the failure with that EcoCode validation happening on the Trino backend on Starburst Galaxy, that took a lot longer than when it passed. And I think the validation aspect is pretty quick. So because you're just running a query on Trino, and then that is leveraging our 20 node cluster, and no problem. The part which I think actually ends up taking more time, I'm like 90+% confident on this, as I was like looking into this earlier today, was that it's when it's getting together all the failure cases. And especially in this case, like we saw, there could be like 160 something thousand failures, quite a lot. And that means that you're having to kind of, in order to report on this, we bring that locally. I think that one of the things we were kind of maybe at some point briefly chatting on was how do we maybe have some new configurability, or maybe there already is something, you know this better than I do, around like how many failure cases we report.
Yeah, it's in there. It's just not really well exposed. Yeah. So.
And I can't remember if I implemented that for the Ibis one. So we'll need to make sure on something like that. Another thing which can be quite challenging with also working with distributed backends is when you're working with pandas, and which is where I guess Pandera started out, your data is gonna be ordered, it'll be aligned, and then when you have like different results failing, it's kind of very easy to just say like, oh, it failed from this row. But all these checks are columnar, and then there's no guarantee with a lot of distributed systems that your results are going to kind of come back in the same order. And so I know that we have like some like looking at like how do we make sure that we're reporting the right thing. I think we can be very confident in most cases that the checks are giving the right result, that if it fails correctly. But I think there's probably still some kind of checking, being confident around like making sure the failure cases for these are actually for the correct rows, because that can be actually a very challenging piece.
Yeah. Hence the, what is it, the row-based join?
Yeah.
Only supported by a few backends. Yeah, this is a great point, kind of going back to our conversation around like the trade-offs you make by making something more specific or more general. Pandera started off making all sorts of assumptions, right?
Mm-hmm.
Data fits into memory, there's an index, you can kind of align things based on that index. And as you said, when you go to a distributed setting, like all those guarantees are off. So I think there's a way forward for sure.
Yeah.
But I think that part of the failure case reporting is super greedy at this point. It's like, just give me all of them.
Mm-hmm.
So I think there can be, massive runtime improvements just by surfacing a few of them, right? Like a few of the unique ones, let's say, because you want to get as much information to the user as possible of like what the nature of the failures are. So that's kind of like one of the strong opinions Pandera takes, is like, we're not just going to throw an error. It's going to try its best to like show you why the thing happened. And now we're kind of have to balance that out with, a distributed, system.
Yeah. And I mean, I think that's fine. Also, like do call this out as like one of the challenges, but like, Pandera works. I mean, Pandera started with kind of local data, working with pandas, many polars, then is added, or even if you're working with like the DuckDB backend on with Ibis, these will all, like, for example, reporting back more failure cases, as long as the data is fitting in memory. It's not a huge deal. And then the good thing is, like, let's say if you are working in distributed settings, data validation is usually not one of those things you're just doing for fun or explore and look around. So if something fails, then that's probably like a showstopper for like your workflow, and you need to kind of go and investigate that, and that's a check that maybe you don't want to continue downstream. So if it takes a little bit longer on reporting some of this, or if some of the things is not correct in terms of like we want to make sure the failure case that reports are correct so we can debug that better. But if it takes a little bit longer right now, and we can definitely try to improve that, I think it's not the end of the world as long as you know that it's failing. The thing is that, especially in the cases where it's correct, you want to be very fast, because let's say that you're working with data like hundreds of millions of rows, and you want to be able to run these checks constantly, and you want to be able to make sure that like when it passes, that works. I also know that you mentioned like, oh, what are some of the other kind of like learning experiences through this? Like, I think one of the things was also like, I really got it. It was really fun also to learn more about how Pandera works. I think it's very easy to kind of be like, oh, that's a data validation library. That probably means you go and just write some checks and you execute them and provide some syntax around it. Not to kind of like really go into it, but like, there's a lot of kind of machinery around like the models and different components and how these kind of all propagate things up, how you can support like returning like first error, or like kind of returning like the whole set, like full set of kind of like failures, and how you can kind of work with different backends that would, I guess, be part of that evolution of Pandera from when it went from just supporting pandas to other things. And I mean, that's, I think, the thing also with a lot of these kind of like open source projects that really grow is like, there's a lot of kind of work and thought that goes into it. And so it's kind of interesting and a learning experience to go through that. This is also like a project that started in, I think I just picked it up like in Christmas time of.
Yeah, you did.
It's been a while. We got that first release out maybe last month.
Yeah.
And so definitely one of the other things was, as Pandera was evolving on the side, being able to kind of like, oh, okay, kind of update this long running branch of the Ibis development. So that's always a fun thing of especially open source projects you're doing on the side.
Yeah. Hopefully that wasn't too painful.
It kind of is what it is, right? Like
Yeah.
I guess if I was just be there like, oh, let me just go work on this for like 3 months straight and quit my job, that would have been a different way to avoid some of that. But like it is like you're used to this in kind of that open source development world, and especially for things which are sometimes side projecty.
Yeah. Well, we are 4 minutes to time. If anyone's in the stream and want to ask any questions, please post them in the chat, and we'll address them. While we're waiting for that, if there are any, what advice would you give to anyone now in 2025 with all the hype, all the stuff, shiny objects? Like, what advice would you give to someone interested in the data and ML space, in the closed or open source, either way?
Yeah, I think one of the things which I'm pretty like I care a lot about is sort of like doing things like quote unquote the right way, or like a somewhat efficient way when these tools exist. I would definitely say be aware of how you can avoid bringing all your for like even like data scientists or like data engineers who are doing things in Python, kind of be aware of how you can leverage some of these tools that exist. Things like Ibis, just where you can do things kind of efficiently. If you still want to do things in Python, you don't always need to do things in SQL. SQL works fine for a lot of these things. Python has its benefits for like for being able to be like more unit testable and things like that. It's also nice to be able to have your data engineering all the way down to your data science code all in one framework, or using one language, especially if you're like a small team, or let's say you're an academic, or you're kind of wanting to not have to maintain more systems. So yeah, I think that's definitely something that I would really push people to kind of be aware of, that some of these great tools do exist. Yeah, and then I think also if you do, I would say like definitely check this out. Check out like I would love it if people check out things like the integration for Ibis, for Pandera, and if you have any issues that you run into, definitely report them, or if you want to even contribute or get started, like that's also super great. I think everyone starts somewhere with contributions to open source, and I think it's a pretty valuable thing.
Yeah, for sure. Well, thank you so much, DPMN. It looks like there are no questions yet, but yeah, we'll hang out for another 2 minutes, maybe chit chat a little bit more. But thank you again so much, DPMN, for joining us. And yeah, we'll see what the future brings. Hopefully, I'll get on certain bug fixes and feature improvements on the Ibis Pandera side as well. One thing in our roadmap is a Narwhals integration, as I mentioned earlier. If people want to reach out to you, where's the best place to kind of keep in touch or reach out?
Yeah, you're welcome to connect with me over LinkedIn, or you can find me on GitHub issues through these projects as well. But if you want to reach me more quickly, you're also welcome to reach out to me over LinkedIn.
Yeah, GitHub it's nice. That's like my main social media.
Good thing that we are basically working on social media for work as well. So there we go.
Nice. Okay, well, thanks for joining, everyone, and thank you, DPN.
Yeah, and thanks, Niels, for having me and doing this. It's been great.
All right, take care.
Yeah.